Hello, this is Joe Trahan, welcoming you to the All Me podcast from the Taylor Hooten Foundation, whose mission is to enlighten the world to the truths about appearance and performance-enhancing substances. As the national leader on this subject, they communicate their educational messages through various methods, including this podcast. Thank you for listening and enjoy the show.
Hello. Thank you for tuning back into the All Me podcast. This is Don Hooten Jr., and today I'll be your host. If you haven't done so already, please hit the subscribe button so that you don't miss an episode. We'd also love it if you could take a minute and give us a review so that more listeners can hear the great content we're offering. Today, we're jumping back into a topic that we've recently been getting asked quite a bit about at our high school and college All Me Assembly programs. Following all of our programs, we like to leave time to take questions from our audience. And in 1 week, I was asked by 2 different students about peptides. While I had a basic understanding of what they were, I felt it was best if we had an expert on the podcast to talk about this topic so that we have a great resource that can help answer this question. In just a few moments, we're going to bring on Dr. John Yates, who is a professor in the Department of Molecular Medicine and Neurobiology at Scripps Research Institute in La Jolla, California. He's going to help us understand at a high level of what peptides are and how they function. I'll make sure that all of the terminology that he references in our interview will be defined in the show notes. Please consider making a donation to the Taylor Hooten Foundation to help support our All Me education programs. We want to say thank you to Gatorade for all of their support, especially for sponsoring this episode. Without further delay, let's bring on our guest and talk peptides. Professor Dr. Yates of the Scripps Research Institute, welcome to the All Me podcast. Thank you so much for joining us.
Thank you very much, and please call me John.
Absolutely. I'll definitely get you as John going forward. And thank you for taking the time out of your schedule to do this. It was great to meet you when we were at the Partnership for Clean Competition conference in New York at Major League Baseball headquarters, which seems like just a few weeks ago. And I believe we're a couple months out now. But what I want to do is we are going to discuss the topic of peptides. And this has been a question that we are starting to get more and more often in high school and colleges. But before we really dive into this main contact, we always like to get to know those that we are interviewing. So let's talk about you for a little bit. And I know some people aren't comfortable with that, but let's talk about and start talking about where, John, where are you from?
Technically from the Boston area. My dad was in the military, so I grew up kind of all over the U.S. I currently live in San Diego, and one of the reasons why I live here is that when I was 10 years old, we lived in at Camp Pendleton, which is in Oceanside, which is just up the road from here. And I was just blown away by how beautiful San Diego was and how great the weather was. So when I got the chance to come back to San Diego, I came back.
I completely agree with you. And as we were kind of talking before our discussion here, I was sharing with you that San Diego's probably my most favorite city in the country. And I'll never forget one time, John, I flew in there. We were doing our annual program with the San Diego Padres. Now, when I took off out of Dallas, it was about 104 degrees and landed in San Diego. And I believe at that time it was 82 degrees. And I'll never forget because I got in the cab and the cab driver was, saying, hey, I'm really sorry. The AC in my car doesn't work and it's really hot today. And I kind of started laughing. I said, this weather is amazing. It was one of my first trips out there and come to find out, I guess that would technically be warm weather. But, I was like, this is a nice break for what I'm used to. But it's, the weather there's beautiful every day. I mean, I guess 82 would be the high, right?
82 would be a heat wave, yes. Normally it sits somewhere around 68, although we have most of the weather is driven by this marine layer thing. That and we get May gray, we get June gloom. Right now it looks more like Ireland than it does San Diego. It's gray, it's drizzly, it's cool, but warmer weather is coming.
For those of you that have never been to San Diego, I highly recommend it. And if you have the time, please visit the San Diego Zoo. We got a chance to do that, and I was probably in my mid-30s at the time. The best zoo I've ever been to in my entire life.
And it's a great spot to bring kids. It's a gorgeous zoo. Highly recommended as well.
Absolutely. So I want to talk more about your line of work and the research that you do. Can you kind of talk about, what line of work you're in and some of the things that you're studying and looking at?
So I'm trained as a chemist, although I have my bachelor's degree is in zoology, which is animal biology. And I have spent my life studying the functions of proteins, but we do so using what's called a mass spectrometer, and to best characterize that and call it the bathroom scale of science. It's how we measure and characterize molecules using these mass spectrometers. And so my field of specialty has been developing mass spectrometry to be able to sequence proteins and try to understand their functions, what they do in the body and so forth.
Interesting. I mean, at what age were you when you started to get interested in chemistry?
So, interestingly, when I was a freshman in high school, I started playing football, freshman football, and first game of the season, probably one of the first few plays of the season, I went in, made a tackle, and somebody came in behind me and landed on my leg and broke my leg. And so I was out. And so I spent about a week in the hospital getting it repaired. It had to be surgically repaired. And I was really fascinated by all the things going on around me. And I got interested in medicine. And of course, if you start thinking about going to medical school or something like that, you start taking a lot of biology, science classes, biology, chemistry classes. And then when I took chemistry as a sophomore or junior in high school, the teacher made nylon. Did this experiment where he mixed a couple of chemicals together and made nylon. I was just blown away by that. Hey, you could make stuff with this field. And so that got me on the track of studying science when I went to college. And I was a zoology major, which is animal biology, which is sort of the typical pre-med kind of major. And I get to take the big, for pre-med, the big class is organic chemistry. It's kind of do or die if you want to go to medical school. So I took organic chemistry, and it came very easily to me. And I wound up with a 98 average both semesters. I said, hey, this stuff's great. And I didn't get into medical school. So I was rethinking what I was going to do, and I thought I would reapply to medical school. But first, I would get into the master's program at the school, which I was in. I studied chemistry in the master's program in chemistry. And so I can kind of, feel out chemistry and see if I liked it. And then in the meantime, I would just reapply to medical school. And I started taking chemistry, and I decided I really liked that more than potentially going to medical school. And I think the fates had the wind at my back, and it wound up being the best decision. I really enjoyed my career in science.
It's pretty interesting if you think back to, when the referee blew the whistle that football game, that was almost kind of like a turning point in your life. And especially, the young people that are listening, I remember even being in college, like, what the heck am I going to do? What am I interested in? And, again, I went and got my degree in information technology, and I minored in computer science. And here I am today doing something completely different. But it's just fascinating how, just you laying in the hospital bed sort of piqued your interest onto something that ultimately led you on to a very successful career.
Yes. Before the broken leg, I was actually a pretty fast runner. And then after the broken leg, I wasn't very fast anymore. After 3 months in a cast and surgery. And so I took up a different sport. I started playing tennis.
Okay.
And I became pretty good at it and played on the high school tennis team. And then senior year, I got back into we had a really good soccer team at my high school. And so all my friends were playing soccer, so I went out for soccer my senior year. Didn't play much, but it was fun.
You are certainly an athlete. Playing all those sports, I know, especially working in and around professional sports like Major League Baseball, the best of the best athletes were playing multiple sports, where I know today you have a lot of young people that just specialize in one sport. But that's really cool, just growing up and how your career path took you. But today you have your own lab. So for somebody in your role, what does your day-to-day look like, and what sort of projects are you working on? So if I were to kind of come with you into, day at your office, what would that look like?
So if you were in my office, it probably wouldn't be all that exciting because I spend a lot of my time writing research proposals and working on papers and just kind of managing the lab. My days of actually working in the lab are long gone. That's unfortunately one of the things that does happen to scientists when they start getting their own laboratories. So I've got 15 people that work in my lab, and they're working on a wide variety of different projects, from trying to study why the protein involved in cystic fibrosis fails to work properly. So we've been trying to understand the mechanism behind that disease. And we also have some other projects where we're trying to understand the some of the mechanisms behind Alzheimer's disease. It's also a protein-related disease. The protein that causes Alzheimer's misfolds. Proteins have these exquisite three-dimensional shapes. If they don't fold properly, then they can cause diseases. So we've been studying that. And we also develop technology. We develop software. We do a lot of different things in the lab.
So what led you to your journey to the Partnership for Clean Competition, where you and I had a chance to meet?
So pretty interesting story. It goes back maybe 20 years. I was invited to talk at a World Anti-Doping Agency conference, a workshop in Stockholm. Okay. It was in December too, so not the best time to go to Stockholm, except we were there at the beginning of Nobel Week, and so that was pretty interesting. And the workshop was centered around gene doping. And so people were 20 years ago, people were getting concerned that athletes might be able to manipulate their genomes in such a way that they could improve performance, and then how we can detect it when they're doing this. And so I went to talk about this field called proteomics, which is the study of proteins, and how we could perhaps use proteomics as a way to look at when people have modified their genome in some fashion. And while I was there, Larry Bowers, who was the chief scientific officer for the U.S. Anti-Doping Agency, was also attending the conference, and we met and spoke. And then a few years later, Larry invited me to speak at the U.S. Anti-Doping Agency conference about peptide analysis, protein analysis. And so I went, and that led to a phone call maybe a year later or so. Larry saying, "I'm working on this thing, and I want to know if you'd be interested in helping." I can't tell you what it is just yet because I'm still working on it. And I said, sure. And then I get the phone call a little while later that starts telling me about how it's put together the Partnership for Clean Competition, and it's going to be a scientific advisory board, and we're going to review grants, and we're going to fund research. And the one proviso was, of course, that you couldn't actually apply for grants from the organization if you're on the USAB, which is common, it would be a conflict of interest to do that. And that was fine with me to do that. So that's how I got involved with PCC.
Interesting. Okay. I was always wondering that backstory, and I was hoping we'd have a chance to talk about it today. But as you know, sort of the background of our story and the work that we do, our podcast that we're recording right now is one of our greatest resources when it comes to sharing information. So really, it's a great tool that we can point people at who ask specific questions about very specific topics. And recently, John, we've had high school students, and it was even a college athlete that were asking us about peptides. And I have a basic understanding of what they are. And we want to obviously keep this super basic as we had discussed. But one of the things that we'll like to do with this episode is when we get that next question about, Don, what is a peptide? Is it like steroids? It is a performance enhancing drug. We can refer people back to this podcast episode. So I guess before really we can begin the discussion about peptides, wouldn't the listeners need to know a little bit about amino acids?
They would, but let me back up even further.
Okay.
And talk about proteins.
Okay.
So proteins are major constituents of us and other animals, and they do a lot of different things in the body. they form the structural components. For example, they form the contractile machinery that makes muscles work, and they are involved in signaling within cells, so telling cells what to do and so forth. And then there are hormones, which are peptide-based, protein-based, and those are involved in circulating through the body and telling like, muscles to grow bigger, or telling women when to menstruate and things like that. And so we've got all these things, and their proteins are made up of amino acids, and they're put together by the machinery inside the cells, and they're put together in a very particular order. So there are 20 amino acids, and so you can imagine what the combinations of all those amino acids might be. And so when you string them together in a long string, the sequence of those amino acids dictates or tells the protein how to fold up. It folds up into some three-dimensional structure. And that three-dimensional structure is important for how the protein functions. And one of the big breakthroughs recently in science is that using AI, people have figured out, and finally, after 60 years, 70 years, finally figured out how to look at the protein's amino acid sequence and then predict how it's going to fold. And that's all using AI techniques, and that's been a huge breakthrough recently. So there are 20 amino acids, and in people, 9 of those amino acids are what we call essential amino acids. And what that means is that our bodies can't make them, and so we have to get them from a food source. And so that's one reason why athletes might take protein supplements and things like that, is to make sure that they're getting enough of the essential amino acids as all the amino acids. Because if you want to build muscle, for example, you've got to make sure you have enough of these amino acids around to do that. And so, but proteins can they can be many different sizes. For example, hemoglobin is made up of 4 different proteins, and they have a total number of 574 amino acids in them. And then on the smaller end, there's a protein which is often called or peptide, which is often called the love drug. It's oxytocin. It's involved in making women contract during childbirth, and that has 9 amino acids in it. So a very small combination of amino acids, but it's that sequence of amino acids which determines what it's going to do. Does that make sense?
No, that makes perfect sense. So when we talk about, I guess, amino acids, what kind of foods would you find them in? Or, also outside of foods, can you just buy, and again, very elementary, right? Can you just buy amino acids in a dietary supplement? Let's talk a little bit more about that.
Yeah. So proteins are involved in almost any, from plants to cows, pigs, just name it. Everything's got protein in it. And the difference, of course, is that you want to have a protein source that has these 9 essential amino acids in them. And there are some plants that don't have them, and there are some plants that do. In fact, one of the big, in the evolution of humans, one of the big advances in agriculture was figuring out what plants have certain essential amino acids. Because if you don't have those, if you miss one of the essential amino acids, you eventually get sick, you get malnourished over time, because you can't build up all the proteins that you need to build up. So you can think about if you have a normal diet, you are usually getting the correct amount of amino acids that you need in order to survive and build muscle and so forth. And if you eat a steak, the steak goes into your the proteins in the steak go into your stomach, and in the stomach we have acid, we have what are called proteases, and proteases are these other proteins that digest up protein in the steak to create amino acids. And so the digestion process starts in the stomach, and then it moves to the small intestine, where you have more proteases being added to try to chew up all those proteins that were in the steak into basically amino acids. And the amino acids can be absorbed into the body, where they can then be used to build proteins that we need.
Okay.
So it comes from a food source. You can, there are protein supplements that are sold that athletes will often use as a way to supplement their diet.
Okay. Maybe I'm thinking an athlete that might be a vegetarian, because I know they do make some amazing, vegan protein powders and that sort of thing. But I guess an athlete might do that to, take a supplement to help increase those proteins, or, I'm even thinking if somebody's just maybe missing some meat in their diet, this is just a good way to ensure that they're getting all the essential amino acids they need.
Yes. If you're a vegetarian, you can usually get those complete proteins from eggs and cheese and
Okay.
which are animal products. If you're a vegan, then you've got to be very conscious about how you go about what foods you eat in order to make sure that you're getting all the essential amino acids. It's much harder to be a vegan than it is to be a vegetarian.
Okay. Yes. Good clarification on that. But so now we kind of have this basic understanding of what a protein is and what an amino acid is. And I'm glad you kind of went back to kind of build this up. Tell us, what is a peptide and what do they do?
So peptides have amino acid sequences strung together in a string. And it's the same thing as a protein. And we distinguish peptides and proteins simply by size. And there's no real hard cutoff of where that size limits. So there are peptides are considered to be the smallest ones, and then polypeptides are a little bit bigger, and then proteins are the bigger ones. And there's no hard and fast cutoff of when a peptide becomes a polypeptide, and the polypeptide becomes a protein. But typically, when people talk about peptides, they may be talking about things which are smaller. Like sort of on the oxytocin class, where there are 9 residues in length. But the other, quite a peptide, I would call, but the other substance that's often used by athletes illegally is human growth hormone, and that's 190 amino acids in length. So it's not typically what we would call a protein or a peptide, but it's more like a protein.
So, and again, with peptides, are we getting them through food? Is this something you could use as a dietary supplement?
No. So, interestingly, if you ingest a peptide, you might as well just eat a steak.
Okay.
Because it's going to go into your stomach and it's going to be digested up into amino acids. And so if you think you're taking a bioactive peptide and you're taking it by orally, you're eating it, it's not going to do anything. It's going to be digested up into pieces. And in fact, if you look at all the drugs that are on the market, and there are an increasingly large number of drugs which are antibodies that are based on antibody drugs, and those are all injected because it's a long-standing principle of that you can't take a drug orally. You can't take one of these proteins orally because they just get digested up. It's like taking out expensive. It would be like eating a very, very expensive steak.
Okay. So I guess
so they have to be injected.
Okay. Yeah. So I guess similar like growth hormone. Like you can't take growth hormone in a liquid and swallow it. It wouldn't have the same benefits as if you're taking that growth hormone and actually injecting it. Is that correct?
Correct. That's correct.
Okay. Interesting. So, let's look at athletics for a second. And, again, you have, the one person that had asked me about, the peptides, as an athlete, what would be the benefit? And we understand that the growth hormone, in fact, we've got some podcasts we've recorded about growth hormone, but what would be the benefit of somebody using a peptide? And I'll kind of phrase the exact question that he asked me, and this might help, or it might not even make sense. But, he said, basically, are peptides like anabolic steroids, but safer?
No. I think taking any drug on your own, any compound, so be it peptide, be it anabolic steroid, whatever, on your own without the guidance of a doctor,
Mhm.
you can potentially do significant damage to yourself.
Mhm.
And it's particularly bad. So this is what I used to warn my kids about when they were growing up. My kids are all now grown up, is that all these things that you buy on the street or you're buying in the dark web or wherever you're buying them, you have no idea how they've been made. So when you get things from a prescription in the pharmacy, and onto it, incredibly rigorous quality control process before they're actually released to the public as drugs. We buy stuff in some back alley somewhere.
Mhm.
I have no idea what standards are being used to produce those things.
Mhm.
And I want to give you an example of the potential dangers of these things. It was back in the 1980s. There were people that started showing up in emergency rooms, young people showing signs of Parkinson's disease. And that's a disease where people can't control their muscle movements. It's more common in older people. Michael J. Fox, for example,
Mhm.
the actor, was diagnosed fairly early, fairly young, with Parkinson's disease. And it turned out that there was a contaminant. I won't use the actual drug name, but it's called MPTP.
Mhm.
It was a contaminant showing up in some street drugs, and it was causing these Parkinson's symptoms. And it was later discovered that this compound was destroying nerve cells involved in movement. And so many of the people that were affected by this wound up having very early symptoms of Parkinson's for the rest of their lives. And so, I mean, the lesson I tried to teach my kids about this was that you have no idea what these people are doing, and they don't particularly care. They make this stuff, they ship it out the door, and they're not going to see the consequences for it. And then only if they ever get arrested, who would they face consequences for it? So it's if you're getting pharmaceutical grade drugs under the guidance of a doctor, that's fine. If you're buying these things on the dark web or in some back alley somewhere, then there's a lot of risk that you're, one, not getting what you think you're getting. Two, you might be getting something that you didn't bargain for, like something that's going to do damage to you.
Mhm. So if like, let's say you were seeing a doctor, what sort of disease or, I guess, ailment might you have if a doctor's looking to prescribe peptides or, a drug, I guess, that would contain peptides? Would that be muscle wasting, malnutrition? What does that question make sense?
So for example, human growth hormone was produced as a drug intended for people who were not growing, who weren't growing like they should. There are some genetic diseases where human growth hormone, either they don't produce human growth hormone, and so they wind up being short in stature, and so you can give the human growth hormone, and people will attain their normal height. And so a lot of these drugs were being developed as a way to correct some genetic anomalies that people might have.
Okay.
Now, another commonly abused, it's not quite a peptide, but another commonly abused protein is erythropoietin, so EPO, which is used to produce red blood cells. And again, this was originally developed for people who are undergoing chemotherapy, whose red blood cells were getting destroyed during the process, and so this would allow them to bounce back. Turned out it was also a great drug for doping because it expanded your red blood cell population, made you more effective at cardiovascular based events. That
was what was being abused in the world of cycling, right? EPO.
Yeah. I mean, that's a perfect sport for it because it improves your oxygenation and so forth, and so you can work harder. So Larry Bowers gave a talk at one of the PCC conferences a few years ago, and he showed this graph of the times in the 10,000 meter at the elite level. And he's showing how they're slowly going down over many years. And then all of a sudden EPO comes on the market, and times just started dropping like a rock. And then put points on the graph where a test for EPO shows up and times climbed right back up to where they were. It's an amazing graph of how this thing works so well.
Interesting.
But you can hurt yourself by not taking it appropriately.
Yeah, and I guess that's really kind of the case with, obviously many drugs and some of the other performance enhancing drugs when you read about these athletes taking them. And one of the things I'll be sure to do, John, is define, so people can go into the show notes and look and sort of define this stuff. Is there anything, with regards to this topic that we're discussing that we might have missed that somebody might need to know? And again, I know we're trying to keep it very basic for somebody that might be in high school or college that's asking about these, but is there anything we might have missed?
No, I don't think so. Peptides can be just as dangerous as anabolic steroids if taken incorrectly. Mm-hmm. And anabolic steroids, have important uses in medicine. But you usually have to have a disease for which they would be useful for treating, and they should be treated under the care of the doctor. Same thing with these peptide hormones and so forth. If they're available on pharmaceutically because they are able to treat certain kinds of diseases, but you can do damage to yourself by taking them inappropriately. And if you take peptide or proteins orally, you're just throwing away your money.
Okay, so that's definitely good to know, especially somebody that's thinking, maybe they've read some incorrect information online. Hey, I want to get some peptides. I hear sort of like the question was, they're safer than steroids, and off they go onto the black market to purchase these things.
Yeah, they've got to be injected, and just that process alone, if not done correctly, can put you at risk for hepatitis, AIDS. HIV is often transmitted by people reusing needles and things like that, or sharing needles. So there are all kinds of risks, and you can infect yourself with just common infections like Staph aureus, which a flesh-eating disease, by not being careful about this. So even the process of injecting drugs is tricky. And people who have to do that, take insulin and so forth, they are taught how to do it. They're given the necessary sterilization equipment, and then they each time they use a new needle, they throw away the old one, so they don't run the risk of infecting themselves with some other kind of pathogen.
That's a great point. So for any of those folks that are tuned in, maybe even you, John, that listen to the All Me podcast, they will know that we have a special set of questions prepared for every guest that we ask at the end of the show. We call this our curveball round. And what I'm going to do is I'm going to ask you the question, think about it as quickly as you can, and give me the answer. Now, this is not related to anything that we just discussed in this call. So you let me know when you're ready, and I'll ask the first question.
Okay, go ahead.
All right. So the first question I prepared for you is, what is your favorite time of day and why?
Morning, because it's quiet.
I was wondering if you would say that. I'm a morning person as well. In fact, we've got two little kids, and I've always been the type, if I go to bed at midnight, 1 a.m, I'm still up by 5, maybe 6 a.m. So I'm the same way. Have your coffee, kind of get going and everything. So I'm a morning person as well. Here is the second question. If you could live anywhere in the world for 1 year, where would it be?
Oh, that's a good question.
And again, money's no object here. Let's say somebody's paying for everything. Sort of, where would you go?
I think I would go somewhere quite unusual. Maybe somewhere in Asia, maybe China. Go see all the sites in China.
My dad did a lot of international business traveling, and that's probably what he would say as well. He loved going to China. So my last question for you, this one's really interesting. We've never asked any of our guests this, so you're first. You're lucky. Would you rather travel back in time to meet your ancestors or to the future to meet your descendants?
Future.
Yeah, I thought the same thing. Any particular reason?
I kind of like to see, in addition to meeting your your descendants, I'd kind of like to see what's going on in the future.
I'm the same way.
Think about how far we've come over just the last 50 years. I mean, just in my lifetime, going from the internet happening to being on the internet constantly with our cell phones.
Yeah,
it's just been amazing.
Yeah, it's almost like with our kids when they want to FaceTime their grandparents. It's like a video chat where I remember when that technology first came out, you had to have a special phone and that sort of thing. But any smart device now, you can video call with somebody, and really it's been revolutionized and was a great tool, especially during the pandemic.
Yeah, it's kind of interesting that 30 years ago, 40 years ago, people were saying, "Oh, we're going to do video phones." And we kept waiting for video phones to come along, and now they're not landlines; they're handheld video phones.
Exactly. Well, John, thank you again so much for all your time. We appreciate your expertise and sharing with us your knowledge on the topic of peptides. I know this will be one, certainly as we're doing our education programs all across America, we can refer people back to.
Okay. Happy to help.
Well, that's it for today's show. Thanks for listening to the All Me podcast from the Taylor Hooten Foundation, a nonprofit organization leading a national campaign to enlighten people to the truths about appearance and performance-enhancing substances and inspiring people to live and compete without the use of these substances. Please be sure to subscribe to our podcast and tune in to our next episode.